In a Turkish study, researchers split 1,000 students into two groups. One worked alone, while the other was handed ChatGPT. This chart shows the initial results. Students using AI significantly outperformed the control group. But when researchers took the AI away, their performance collapsed. They performed worse than the students who never had access to the technology at all. This reveals a phenomenon called the cognitive crutch. The AI provides a temporary boost to output while simultaneously hollowing out the student's retention of the material. Unrestricted AI use creates a convincing illusion of competence. It masks the lack of learning until the tool is removed, leaving the user with a net deficit in knowledge and skill. We generally refer to this outsourcing of mental effort as cognitive offloading, but its impact depends entirely on who is doing the work. When an adult professional delegates a task like coding to an AI, they already possess the foundational judgment to evaluate the machine's work. They are offloading a task they already understand. But when a student uses AI for those same tasks, they are substituting the micro-judgments required to build their analytical reasoning. They are trying to build the bridge without the pillars. This leads to a phenomenon called epistemic sloth. When a student routes their thinking through a single language model, they inevitably adopt that model's specific biases and prepackaged reasoning structures. In an educational setting, prioritizing efficiency over effort trades cognitive development for automated results. It risks leaving students unable to reason through complex problems on their own. The primary risk here isn't the software itself, it's the lack of a pedagogical framework to guide how the student uses it. This study from the University of Hong Kong addresses a central question. When a learner uses AI, are they extending their thinking or replacing it? There is a thin, invisible boundary between support and substitution. Educators call the space where real learning happens the zone of proximal development. This is the gap between what a student can do alone and what they can achieve with the right kind of guidance. This page from the study identifies a severe risk. When a student uses AI to simply generate an answer, like pasting a calculus problem into a prompt and copying the result, they experience an illusory understanding that bypasses the actual learning process. But consider the same tool used for extension. Repositioned as a tutor, the AI can ask the student guiding questions, like prompting them to identify a missing vector in a physics diagram, which keeps the cognitive struggle alive. A student retains their agency only when the AI serves as a dynamic partner, ensuring the intellectual heavy lifting remains with the learner. This concluding text highlights that AI's educational value is a product of how we position the student within the activity. Our current challenge in schools is a problem of structural design. To counter the path of least resistance, our schools must build intentional friction back into the learning process. One strategy is hybrid brainstorming. By mandating an initial no AI mind map, teachers ensure a baseline of independent thought before the student uses machines to refine their work. Another is the scaffolded debrief. This requires students to expand on a simplified AI summary, forcing them to identify the real-world complexities and nuances that the machine inevitably missed. These frameworks force a confrontation with complexity. They take an automated shortcut and turn it back into a rigorous cognitive workout. We can go further with an AI bias audit. This turns classrooms into a safe playground where students are tasked with hunting for inaccuracies and hallucinations in the AI's output. Generative AI is prone to sycophancy. It tries to give you the answer you seem to want. Auditing these outputs trains the developing mind to distrust and verify digital information by default. Moving forward, AI serves as a synthetic reasoning engine, a powerful system that always requires a human pilot to remain effective. By architecting friction into our education, we transform the technology from a simple answer machine into an intellectual sparring partner. This ensures the next generation remains sharper than the tools they use to extend their reach.